I create a Born-Markovian operator with a reinforcement learning procedure and a quantum neural master equation to calculate the optimal policy of the agent and the transition probability of states. The master equation is a partial differential equation. A partial differential equation contains multivariable functions and their partial derivatives. I use it to calculate the probability of a state at a point of time. The random variable has a certain value at a certain point of time given its previous value at the previous point of time. A quantum master equation is a generalized master equation which I derive from the principles of quantum mechanics. The equation calculates the relationship between the system Hamiltonian, the environment Hamiltonian, and the Hamiltonian for the interaction between the system and the environment. I calculate the probability of the transition of eigenstates of the Hamiltonian operator in the Hilbert space. These eigenstates of the Hamiltonian operator correspond to energy states. The result of the equation indicates the probability that the system is in a particular state at a particular point of time. I choose an equation with Markovian properties to develop quantum Markov processes. I construct a classical Markov chain in an open quantum dynamical system. A Markov chain is a stochastic model which calculates a sequence of possible events. The probability of each event depends on the state of the previous event. One example is the Born-Markov equation. Physicists use the Born-Markov equation in the realm of onboard quantum computing. I apply this master equation to the software. The Born-Markov equation refers to the mass and angular frequency of the environmental harmonic oscillator. I create a Born-Markovian operator with a reinforcement learning procedure and a quantum neural master equation to calculate the optimal policy of the agent and the transition probability of states. Temporal locality is a property of the quantum master equation with Born-Markov approximation. I use the secular approximation to find the global master equation which drops the functions of time in the Born-Markov master equation. I combine the global and local master equation. I interpret a differential equation as generalized Q function. It's possible to combine the reinforcement learning procedure with a recurrent neural net which calculates a quantum master equation for Markovian processes.